Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on ring theory, lecture number 7, in which I will solve some problems on units of a ring. Now we solve a problem. Problem is, if A be a unit in a ring R with unity, then A is not a divisor of 0. Now we prove this. Prove. Let R be a ring with unity and A be a unit in R. Unit means it has multiplicative inverse in ring R. Therefore, A has multiplicative inverse, A inverse in ring R. Therefore, A multiply A inverse equal to A inverse multiply A equal to I, unity. This is number 1. Let B belongs to ring R such that A multiply B equal to 0 implies that A inverse multiply A multiply B equal to A inverse multiply 0 implies that A inverse multiply A by associative law. This will come in a bracket, and right side is A inverse multiply 0 is 0. We know that product of any element with 0 is 0 by associative law. Implies that this is unity I using 1. A inverse A equal to I, unity. This is equal to 0 using 1. Unity multiply B is B. Here we see that AB belong to ring R and A multiply B equal to 0 implies B equal to 0. That means A is not left divisor of 0. If B would not be 0 and A multiply B equal to 0, then A would be left divisor of 0. Therefore, here A is not left divisor of 0. Again, let C belongs to ring R such that C multiply A equal to 0 implies that C multiply A inverse equal to 0 multiply A inverse implies that C multiply by associative law A multiply A inverse equal to 0 multiply A inverse is 0. Associative implies that C multiply A inverse equal to unity element I equal to 0 using 1 implies that C equal to 0. Here C and A belong to ring R and we have assumed that C multiply A equal to 0 implies that C equal to 0. That means A is not right divisor of 0. Therefore, A is not right divisor of 0. This is number 2 and this is number 3. In 2, A is not left divisor of 0. In 3, A is not right divisor of 0. Therefore, from 2 and 3, A is not divisor of 0. Proved. Now, we must remember this note. If A be a divisor of 0 in a ring R, then A is not a unit in R. By an example, we may see this. Here, Z6 contains elements 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar. Here, 2 bar belongs to Z6, 2 bar not equal to 0. Also, 3 bar belongs to Z6 and 3 bar not equal to 0. But 2 bar multiply 3 bar means 6 bar means 0 bar. Here we have no element like 6 bar. So we have to divide this 6 by 6. We get remainder 0. So this is 0 bar. Similarly, 3 bar multiply 2 bar equal to 0 bar. Here we see that 2 bar, 3 bar not equal to 0, but their product is a 0 element. Therefore, 2 bar is a divisor of 0. We may not get any element 2 bar multiply x bar such that this is 1 bar unity element. If we take 0 bar here, 2 bar multiply 0 bar is 0 bar, 2 bar multiply 1 bar is 2 bar, 2 bar multiply 2 bar, that is 4 bar, which is not equal to 1 bar, 2 bar multiply 3 bar, 6 bar means 0 bar, 2 bar multiply 4 bar, 8 bar means if we divide 8 by 6, we get remainder 2, that is 2 bar. 2 bar multiply 5 bar, 10 bar. If we divide 10 by 6, we get remainder 4, that is equal to 4 bar. So 2 bar multiply x bar not equal to 1 bar. We may not get any element x bar in Z6 such that 2 bar multiply x bar equal to 1 bar unity. So 2 bar is a divisor of 0 and 2 bar is not a unit. Unit means this element has no multiplicative inverse. Now we solve the next problem. Next problem is the set of all units in a ring R with unity form a group with respect to multiplication. Now we prove this. Let R be a ring with unity and let U equal to set of all units in ring R. I be the unity in R, since R be a ring with unity. Unity element in R is I. And we know that unity multiply unity equal to unity. Therefore, I has multiplicative inverse I in R, ring R. Therefore, I is a unit in ring R. I is a unit in ring R means I belongs to U. U be the set of all units in R. Number 1. Let A, B belong to U. U be the set of all units, implies that A and B are units in R, ring R, implies that A inverse, B inverse exist in ring R. Therefore, A multiply A inverse equal to A inverse multiply A equal to unity, and B multiply B inverse equal to B inverse multiply B equal to unity. This is number 1 and this is number 2. Since ring R is closed with respect to multiplication, therefore A multiply B belongs to ring R and B inverse multiply A inverse belongs to ring R. Now, A multiply B multiply B inverse multiply A inverse equal to, by associative law, A multiply B multiply B inverse multiply A inverse equal to A multiply, here also by associative law, B inverse multiply A inverse, and this is equal to A B inverse B unity element multiply A inverse equal to A multiply unity element multiply A inverse is A inverse, this equal to unity element. This is number 3. Again, B inverse multiply A inverse multiply A multiply B, this equal to B inverse multiply A inverse multiply A multiply B by associative law. This equal to B inverse multiply, again by associative law, A inverse multiply A multiply B, and this equal to B inverse multiply A inverse A is unity multiply B, this equal to B inverse multiply unity multiply B is B, and this is unity. This is number 4. So A multiply B inverse A inverse equal to unity, and also B inverse multiply A inverse multiply A multiply B is unity. Therefore, A multiply B inverse multiply A inverse equal to B inverse multiply A inverse multiply A multiply B equal to unity. Therefore, B inverse multiply A inverse is the inverse of A multiply B. Therefore A multiply B is a unit in ring R, implies that A multiply B belongs to U. U be the collection of all units in R. Hence we get AB belongs to U, implies that A multiply B belongs to U. This means U is closed under multiplication. Means closure law holds in U. Now we have to show that associative law holds. Let A, B, C belong to U and U is subset of R, implies that A, B, C belong to R ring. Therefore A multiply B multiply C equal to A multiply B multiply C. Therefore associative law holds in U. Number 3. Since I be the unity in ring R, implies that I multiply I equal to I. Therefore I be the multiplicative inverse of I. Therefore I is unit in ring R, implies that I belongs to U. Let A belongs to U, implies that A belongs to ring R, implies that A multiply I equal to I multiply A equal to A. Therefore I is the multiplicative identity in U. Number 4. Number 4, existence of inverse. Let A belongs to U, means A is a unit in R, implies that A is a unit in ring R, implies that A inverse exists in R and A multiply A inverse equal to A inverse multiply A equal to unity element. Here we see that A inverse multiply A equal to A multiply A inverse equal to unity element. Therefore inverse of A inverse is A. Inverse of A inverse is A belongs to ring R. Therefore A inverse is a unit in R, implies that A inverse belongs to U. Therefore for each element in U there exists A inverse in U. Therefore, from 1, 2, 3, 4, we see that U with binary operation multiplication holds closure law, associative law, existence of identity element means existence of multiplicative identity, and existence of inverse. Therefore, U with binary operation multiplication is a group. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.